question right now is, should we migrate? Should we migrate from VMware to something else? And I think the most important question to ask is why? If we look at what VMware has been doing over the, well, let's say more than 20 years, is providing a consolidated hardware platform, running in hypervisors to consolidate all the virtual machines into one hardware. So it's a way of being more efficient with your physical hardware, right? They've been adding a lot of really nice functions and features. I think the best thing that VMware actually created was VMFS. It's a data store, which is read many. It's a shared data store between hosts. If you really look at what is this actually are creating for you as a VMware administrator, a data center administrator, is something very unique. So when you're looking for an alternative, will that alternative, at least from running a virtual machine perspective, be as good as VMware's VMFS as a shared data store? I'm not really talking about vSAN. I'm talking about the traditional data store that they came up with almost immediately to run SAN and attached or shared attached storage for multiple hosts. Another thing with VMware is it's very feature rich. It's very easy to work with. But I think where VMware is struggling is to be relevant out of a Kubernetes perspective. But if you don't need Kubernetes or think you need Kubernetes, VMware is still probably the best way of running virtual machines. Is it the cheapest way of running virtual machines? Well, that's up to your license agreement and your license type you have with VMware. But I think the investments done in VMware over the last 20 years, at least from a competence, knowledge perspective, a lot of people in the market actually knows exactly how to work with and run workloads on VMware or with VMware technology running your virtual machines. That's also a factor to look into, because these 20 years of actually knowing exactly how VMware works, or vSphere or ESX works, isn't always, or isn't something you should just, get rid of or overnight. So factoring the costs of running with even the new licensings from VMware, you also need to factor in the software, or sorry, not the software, but the soft costs, like the people, the retraining costs and something like that, before you leave for something else, at least for the only reason of looking for something that is cheaper to run virtual machines. So the lack of functions in the alternatives might be a factor for not moving. Software costs, soft cost, like people, training and stuff. It's very important. So reason to move away from ESX I think should be decided based on workloads. Okay. It's very popular actually to run Red Hat OpenShift in VMs running on top of VMware, vSphere. But when you come to a stage where you see that most of your workloads are going to be container-based, running containers in an abstraction layer or orchestrator like OpenShift on top of a virtual machine hypervisor might not be the most efficient way, both from a cost, but also from a resource management perspective or complexity, right? OpenShift is complex. It's not as simple as running in hypervisor. And the reason for that is OpenShift isn't a hypervisor. It is an orchestrator to run in container-based workloads and virtual machines inside containers. I think we're going to hopefully come back to what I mean with running virtual machines in containers a little bit later. But one of the big things, differentiators between VMware and OpenShift, is actually automation. As I said, OpenShift Kubernetes is an orchestrator that's built from the bottoms up, ground, base core functionality. OpenShift is automation. You automate everything, and the focus isn't on consolidating virtual machines efficiently on hardware. It's application-centric orchestration. So everything is around applications and running applications. The operating systems is usually something you don't really care about anymore when you're running containers. It's how you deploy your applications, how you automate the deployment of applications. I think the big differentiator I use to explain this is that when you're running an application that is of a monolithic structure, that is part of that you run on a virtual machine or a couple of virtual machines. Let's say you have a GUI, an application server, and a database, and 3 or more virtual machines. You install them and you lifecycle management them with upgrades. And if shit hits the fans, hopefully you have a backup, you will restore it. With container-based workloads, microservices that you running or orchestrate with OpenShift, you are not installing applications anymore. You're deploying applications. And if shit hits the fan, you redeploy them. So most of the applications, if they're well written, will be stateless. They will not have any information stored in containers. They will, if an application needs to hold some state, it will have a database engine or multiple running on multiple nodes at the same time, replicating. And that is the stateful storage part of that. And in that, of course, you need to either replicate synchronous or asynchronous, doing snapshots of the database, whatever, or you need to actually do a backup so you can restore that one. But the rest of the application are supposed to be stateless. So you never install them, you just deploy them. And you do that by script and automation. That's the biggest difference. So OpenShift is a new operational paradigm because it's not about consolidating, it's about running applications and giving it the application developers an easier way of working with continuous upgrading and continuous deploying new functions and features and bug fixes in application in a way that makes sense for them. So as a VMware administrator, I've been accustomed to take care of the infrastructure, deploying virtual machines, maybe an operating system on the virtual machine, but that's about it. Now with OpenShift, you're actually creating a platform for application owners and developers, mostly owners in operations, of course, to run their application. So that means that you as a VMware administrator now needs to look at understanding the platform the applications runs on. It's not just operating system and now the application owner will take care of everything themselves. You need to step up. It's an extra step up in responsibility because now it's more like, it's really way more like creating a platform as a service internally than infrastructure as a service. So working with application owners, let's say where the ones that are actually deploying the application have some responsible application, not developing specifically, you need now to have an interaction or integrated with them how to work with automation so they can have the right tools, like multiple kind of storage classes, multiple kind of networking, external networks, at least from the application perspective, so they can automate their deployment, lifecycle management of their applications against that. So you're creating services now more than just a virtual machine and maybe some operating system kind of image install. And in most cases, the backup restore of a container-based application will only be on the stateful part, not on the whole installation, because it doesn't matter. If the application goes down, you redeploy them by scripts. So more of a infrastructure by code, application delivery by code kind of approach than you might be used to. Another thing that is super important to understand about OpenShift, there's nothing like super admin, right? It's not like a super admin or admin, whatever. everything, because this orchestrator runtime is made for multiple users, and it's built from ground up based on a multi-user approach. So role-based access is, you have to go in and you have to look into role-based access. You don't work like you probably did in VMware or other virtualization products where it's deploying a virtual machine. Well, whatever. Let's work with the admin or a super user or something, and you're home and everyone's doing that, and it's kind of a, let's agree not destroy too much or be in the way for each other, but everyone's more or less using the same role. With OpenShift, it's not like that. You really need to understand RBAC and roles for users, because it's built around that 100%. So let's say you adopted a migration strategy to move virtual machines to OpenShift. What do? Right? What do I do with my old hardware? Should I buy new hardware, or should I repurpose? What should I do? Well, it depends on the size of the installation, of course. An OpenShift installation had some basic, there's some basics in what kind of hardware is needed. So you need 3 controllers to control the cluster, or clusters, but control the cluster. And you need 1 to 3, hopefully, minimum 3 workers where the workload, your applications are running. There are some exceptions to this. You can actually do 2 nodes, mix the controller and the worker roles on the same physical hardware, and have 2 nodes and a witness to make sure that you can do failover between and detect if one of the hosts are down. Or you can do what's called a compact cluster, where you have to have 3 nodes that you're mixing the controller and the worker roles on the same hardware. Works well with workloads that exactly what's needed from a memory and CPU perspective. So you're not overcommitting anything. But the recommended way is having 3 separate controllers at least, and have as many workers needed for your workload. Difference here also is when you are repurposing or thinking about repurposing or configure some hardware for the workers, it's very important to think to understand this, and that is containers needs vCPU more than memory. Virtual machines are usually constrained on memory and can overcommit and reuse CPU very easily. And the reason for that is with containers, you actually have something called reservation of vCPUs. So when the application has been, the developers have set a minimum amount of cores of vCPUs needed for this application to start and run good, from a minimal config. And that's been defined in the definition of the project, or the application in this case. So when you are deploying an application on OpenShift, it will look for this amount of free vCPUs so it can do a reservation so it can start. If you don't have enough vCPUs available, the application won't even start, because you're actually not giving it the minimum reservation defined by the application. That doesn't work. It works completely different to a virtual machine is. A virtual machine will look for memory. It doesn't get enough memory, it will not start. Or it will, start swapping, or it will be super slow, right? But it's a hard stop for a container-based application having vCPUs that it can reserve, okay? And that means that, let's say you have a few cores, a lot of memory, that's a host for virtual machines. And in this case, you want to run containers, and now you don't have enough cores, but you have a lot of spare memory. So there's a completely different kind of hardware spec for it. So let's say you have a fairly large installation. So you have a couple of ESX hosts, let's say 6, 7, 8 ESX hosts with corresponding virtual machines running on it. you want to repurpose that, and you want to start migrating virtual machines over to OpenShift, because you can run virtual machines there and container-based workloads. You create a new cluster, basic cluster with 3 controllers and a couple of hosts, and you start migrating some virtual machines over to that one, so you can start reusing your old ESX hosts if you want that. I mean, if they're not too old. And then you create something called a hosted control plane. It's a feature function that's been part of Kubernetes 2.5 years. OpenShift, as it's a supported version and a supported package with some add-ons and a lot of extras on top of Kubernetes for enterprise use of Kubernetes. That's what OpenShift is. Also been an integrated part with some extra functions running hosted control plane. A hosted control plane is a resource cluster. It creates a couple of controllers. So it creates 3 virtual machines, or not virtual machines. It's actually not virtual machines, but 3 controllers running in the base cluster, the physical cluster. And then you can actually add both virtual workers, which will be virtual machines running OpenShift and being deployed as workers to that hosted control, that resource cluster. Or you can actually use bare metal host or physical host. It actually, in this case, maybe your old ESX hosts, because they're well configured for virtual machines. And add that to it and have your own namespace for virtual machines. And you can also put your own license type there. You can actually use subcapacity or completely separate license on that virtual or resource cluster on top of the physical cluster, because it's its own namespace. And because it's its own namespace, it's allowed to have a separate virtual. You can actually only have an OpenShift license called OpenShift Virtualization running on that one. Is way cheaper than license the whole cluster, physical cluster, and all the other the virtual resource clusters around that with a higher license type like OK or OCP or something like that, which is way more expensive. But of course, it's more expensive because it's got more functions and features. But it's not necessary when you're only running virtual machines. So start repurposing your old ESX hosts and put them into a hosted control plane, license them specifically for that, and make it more cheaper. And now you can also reuse your infrastructure. You don't need to build a completely new cluster from scratch with the full capacity. Just reuse the old hosts coming from there. So another interesting thing with OpenShift is you can run multiple architectures in the same cluster. So you can run x86, Intel AMD, as usual, as you're accustomed to. But that's been a kind of a limitation by VMware only supporting x86. Well, it had a small stint looking into ARM, but it's mostly an x86 play. OpenShift is supported on IBM Power, the PPC architecture. They also you can also run ARM. You can run IBM's mainframe, the SET or the S390, I think it's called, the architecture in Linux. You can mix and match. You can have it in the same cluster. That means that an application now can actually run on the most efficient kind of architecture for whatever reason, license reasons. It could be like you need a lot of small, high count of cores because you want to run a GUI or a web service of some way, shape, or form. So you need a lot of cores. So why don't go for ARM? ARM is easy to have a lot of cores, cheap. Power consumption isn't that high. And you can manage that from the same cluster where it's just about tagging an application, label tagging application, and the orchestrator, OpenShift in this case, will just put it on that server that has, or that worker that has the right architecture for that workload. Power is very much known for being a good license optimization architecture for SAP, DB2, and a lot of Oracle platforms, because it can run a lot of workloads on few cores. And if you have a license that's core-based, it will be more cost effective for it. So as it's not a hypervisor, it's an orchestrator. You can pull in all these different architecture and running them on the same cluster with the same management, either in hosted control planes. So you can have a Power hosted control plane. You can have IBM Linux One hosted control plane. You can have ARM hosted control plane with bare metal host running in that whole. So you have separate namespaces and easily just move workloads between them. So let's go into migration of VMs. There is a tool called MTV, which is a pretty cool name, that is available free of charge, that you can use to migrate into OpenShift. Virtual machines from VMware, from others, OVAs, whatever, back and forth. It's a multi-directional toolkit. It's so simple using it, so I won't even show it, but it's very a point and click if you want to do it manually. Or there's some very simple YAML files you just fill in. You define a provider like vCenter or Red Hat virtualization and the Rev, the old the virtualization product from VMware, from Red Hat, or whatever. And you get a list. You choose which VMs. You choose if you want to do a hot or a cold migration. Cold migration, both the source needs to be off, powered off, and you move everything in one step. Or you can do a hot migration, where you take a snapshot of the source. It will replicate all the data over to OpenShift, and then you elect the time where you do a sync. And it will come up on the other side. It also, in that way, you're also describing the new network, the new storage pools, whatever you want to put your virtual machine when you in OpenShift. But you do that in that script, or you do that in that workflow, the manual workflow. Super simple. It works well. It always works, kinda. I'm saying this because when you do any kind of change, you need to think about the prereqs, right? If you've been doing virtual machines, movement or migrations, or maybe upgrades and stuff in VMware for a long time, you know there is two things that might create issues. One is VMware tools. They could be very old, or VM hardware version, or hardware version. Hardware version is something that's been generally overlooked by a lot of virtual machine or VMware administrators every year, because it's only adding like functionality when you're upgrading. If you have a very old operating system, you won't really maybe see some benefits, and only add some risk when you've been doing this. But if you're moving away from VMware to something else, in this case OpenShift, it's very important to make sure that you are on the latest, greatest supported level for VMware tools and hardware version on every single virtual machine. And another thing is there is some issues still, and important looking into this is, if you look at the virtual machines, a virtual machine, and you allocate the vCPUs to it, there is a high risk that it's been allocated. Let's say you have 8 vCPUs, that all of them are been allocated at 8 sockets or physical CPUs, instead of maybe one socket with 8 cores. That makes a lot of difference from a scheduling perspective around CPUs for virtual machines. It's even more important when you're migrating that you fix these problems before you migrate. So there is some prereqs and pre-work that needs to be done. Fix the VMware tools, fix hardware versions, and make sure they're on the latest, greatest version that's supported by the operating system running in that virtual machine. And make sure that you have the right amount of memory allocated to it, if not overcommitted, but not undercommitted. And make sure that you have you're using logical CPUs as much as aka virtual cores as much as possible, and reconfigure the virtual machines before you do the migration. Because you will have issues if you're moving shit. You will have shit on the other side too, and it will potentially create a lot of issues. And after you migrated everything, and just add, when you do a hot migration, you know the source is still working or running on the virtual machine, you can actually test the application or the operating system and everything on the virtual machine OpenShift